This is a ramble through the night sky, a rather laid-back look at what you can expect to see in the night sky. So I'll be talking about what is up there, I'll be talking about how you can find your way around, and what if you want to see more than you can see just with the naked eye. And I'll be trying to answer the question, what if I want to photograph what it is that I see in the night sky? So note that this is not an attempt to describe everything that is up there. It's more of a random walk through the universe, or another way of looking at it. This is a bit of a dog's breakfast of some of the images I've taken over the years, and it's just an excuse to show you some of those images, either with or without a telescope. So we can start by asking what is up there. And one of the closest objects that we can see, with the possible exception of meteors, is the Aurora Borealis. This is within our own atmosphere, right at the top of our atmosphere, not usually seen from the United Kingdom, but if you go, for instance, on holiday to Scandinavia or Iceland or perhaps Canada, then you stand a chance of seeing the Northern Lights. And it is quite a spectacle. When the Northern Lights really get going, they can absolutely fill the night sky. They're not just a little bit of a glow on the horizon. The entire sky can light up with the green, blue and red glow of the aurora. In this particular case, perhaps you can see that over on the left-hand side is the constellation of Orion. There's the three belts of Orion, and in the middle there's the Seven Sisters, the Pleiades star cluster. And you can see that the aurora are lighting up most of the sky. These are pictures that I took from Iceland about 20 or so years ago. And of course, if we go a little bit further than our own atmosphere, our closest neighbour out there in space is the moon. And we should never forget that although sometimes the moon stops us seeing the rest of the night sky very clearly, it can be really fascinating to see the detail in our closest neighbour, to watch the changing shadows as the phase of the moon slowly changes night after night. In some cases we can watch the moon during the course of a night and again see the sun change the shadows on the moon and see features revealed as the sun angle slowly changes. So although it can sometimes be frustrating to want to see the night sky and want to see the stars in more detail and realise that a gibbous moon is stopping us from doing that, never forget that the moon is a wonderful sight on its own account. Sometimes we have visitors to our solar system. For instance, Comet Hale-Bopp here, again quite a few years ago now, photographed here with the wide-angle lens, and a view through a small telescope can show us the nucleus of the comet and its two tails. But of course we can't predict exactly when comets are going to come around, and we can't really predict how bright they're going to be. But the planets themselves, that's different. We know where the planets are going to be and we know how bright they're going to be, and we can predict that with very high precision. And although Jupiter and Saturn, the giant planets, can be spectacular sights through a small telescope, some people have said that although it's a wonderful sight, they're often surprised at how small Jupiter and Saturn look through small telescopes. So they appreciate that these planets are a long way away, but as they've been told that these are giant planets, gas giants, a lot of people will assume, if they haven't looked through a small telescope before, a lot of people will assume that Jupiter and Saturn would look much larger. And some struggle to see fine detail on the surface of Jupiter or the rings of Saturn simply because they are rather small as viewed through a small telescope. So again, if we look at Saturn, it's one of the greatest wow factors you can have in amateur astronomy is to see Saturn for the first time. There are so many stargazing and outreach events where when you show somebody who's not expecting to see a planet, you show them Saturn and they are truly gobsmacked by the experience of actually seeing it for the first time. But quite often the knee-jerk reaction is, it's fantastic, but it's quite small. Can't we make it bigger? And the answer quite often is, well, you can see a certain amount of detail by looking through a telescope, but if you use a greater magnification, you're not necessarily going to see anything more. If it was slightly blurry in the first place, it's going to be even more blurry by the time you magnify it any further. So it is possible to get wonderful images of planets using specialized astrophotography, but having high magnification on a planet is not necessarily going to show you the fine detail that you might expect, especially if your expectation is based on what you see with the Hubble Space Telescope rather than what you're likely to see with a small amateur telescope. And if we ask ourselves what's up there beyond our solar system that we can expect to see in the night sky as amateurs, well, there are glorious sights to behold when we look out into the rest of our galaxy. There are stars, of course, scattered everywhere. Our galaxy contains many hundreds of billions of stars. Most of them we can't see because they're too far away, but there are thousands, if not tens of thousands and hundreds of thousands of stars that are close enough to us for us to get a handle on using either our naked eye or binoculars, or, as in this case, using a camera to take photographs of the night sky. This particular area is an area in the constellation of Scorpius, so that's the red giant Antares. It comes out looking a little bit yellow in this photograph, but Antares is surrounded by a hydrogen nebula which is glowing from the light of Antares. Just next to Antares there's a star cluster. This is a globular star cluster, a very compact star cluster, and it goes under the Messier number of M4, the fourth item in Messier's catalogue of objects which are not comets. He was a comet hunter and he got frustrated by continually finding small fuzzy objects which were not comets, so he decided to catalogue them all, and this happens to be the fourth one in his catalogue. A star further over to the right is called Rho Ophiuchus, and that's a beautiful triplet blue star which is lighting up again the nebula around it, and so producing this wonderful colour contrast between Antares glowing a sort of yellowy orange and Rho Ophiuchus glowing blue. And you notice in the same area there's not only the yellow and blue colours, there's some dark clouds as well, blocking light from more distant stars. So in this one relatively small field of view, taken with a modest telephoto lens on a camera, you can see there's an awful lot going on. We see close stars, we see distant stars, we see different colours, we see different structures. Some of this can be very difficult to see with the naked eye, and so you would need to use binoculars or a small telescope, or take long exposure photographs to try and bring out these structures and bring out these colours. And I'll be saying a little more about photography in just a short while. When we look out, when we look out into the universe, we find lots of nebulae, we see lots of structures, but within our own Milky Way, we see not only a large collection of stars, we see quite often pink or slightly reddish coloured nebulae. Pink is a characteristic colour of hydrogen, and there's an awful lot of hydrogen out there, and therefore there are a lot of nebulae that glow subtly in the pink or red end of the spectrum. This is the so-called Rosette Nebula. This is just a little bit further east than Orion, so it's visible in our skies just at the moment. This picture was taken just a few weeks ago. And this is an area of star formation. You can see roughly in the middle of this particular region glowing pink, there's quite a few stars nestling in the centre of the nebula. And so this is a star-forming region. This is a region of hydrogen in which stars have been born relatively recently in the centre of this nebula. It's effectively a sort of stellar nursery, if you want to think of it that way. And we can often see sights again through binoculars, through small telescopes, occasionally with the naked eye. We can see these nebulae in the sky. And these are signs of where stars are being born. But again, the more we look, the more we find, and sometimes we see characteristic nebulae which are signs of stars coming to the ends of their lives rather than stars being born. Perhaps you notice that this photograph looks a little more ropey than the last one. The stars aren't quite circular. The image has drifted slightly during the exposure. This particular picture was taken perhaps 20 or so years ago. I think it was one of my earliest attempts at astrophotography, and hence it's not the best image that's out there. But it's a nice image because it shows what happens to a star when it comes to the end of its life. In this particular case, the star right at the center there, what's left is right at the center of the nebulae, but as the star came to the end of its life and it used up its fuel, it sloughed off the outer layer, the outer atmosphere of the star has been ejected into space, and what we're seeing is the rather tenuous outer atmosphere, which is now effectively being thrown out of the star and is now forming a shell of gas around that star. This is a so-called planetary nebula. Nothing to do with planets, it's simply because it's roughly circular, and depending on the size of telescope you use to look at this, it can give the impression of a sort of ghostly planet, and that's how they got their names some years ago. So a planetary nebula is what happens at the end of the life of a relatively low mass star. For instance, our own sun, when it comes to the end of its life, is going to turn into something like this. The outer atmosphere is going to produce a shell of gas, and what's left at the very core is going to be a white dwarf star. When I took this photograph, I was interested to note that the colours were just about right for what I was expecting, and I was using as a guide a Hubble Space Telescope picture, which is shown in the inset there on the right. Now, I admit that the Hubble Space Telescope picture is better than mine. That's fair enough. But the Hubble Space Telescope cost about $1 billion or two, and my camera cost substantially less than that. So you should never think that you will ever compete with the fantastic images that are produced by professional telescopes. But that doesn't stop you having a crack at taking your own images or simply observing the objects that have been photographed with the Hubble and other big research professional telescopes that are dotted around the Earth. So simply getting an object which looks vaguely similar to the Hubble Space Telescope image can be hugely rewarding, as long as you remember that you are, of course, not trying to compete with it, but simply trying to emulate it as best you can. I said that this particular object we're looking at is the death throes of a relatively low mass star like our Sun, but if a large star ends up coming to the end of its life, it can die not by simply shedding the outer atmosphere, the outer layers of the star, and then forming a white dwarf at the centre. A massive star will end its life probably in a supernova. And this is a supernova remnant. It's the remaining gas that's left over after a star blew itself apart. There's essentially no trace of the original star somewhere in the middle here, but it produced a spherical shell of gas, and we can see some of the shock waves produced as that shell has expanded over the years and ploughed its way into the interstellar medium. So this star probably ended its life somewhere between 10 and 20,000 years ago, and it's a few thousand light years away. It's a tricky thing to see with naked eye or a small telescope, simply because the nebula itself is not as bright as indicated in this photograph. And that's something else to bear in mind whenever you're looking at photographs and then going out at night to actually see something with binoculars or a small telescope. If you're comparing it with a photograph, it'll never look quite the same, because a photograph is adding up all of the light it collects over a period of many minutes, maybe an hour or two, whereas your eye is just telling you what is entering your eye on a second-by-second basis. So the nebula will never look as bright as you can possibly get in photos, but it is possible to see both parts of this nebula, this supernova remnant, in a small telescope. I was at a star party last year in which I observed this through a telescope. It helps to have a nice dark sky, but it is possible to observe these objects as well as photograph them without using a telescope. If we look a little bit further than our neighbouring stars and other nebula, eventually we see the Milky Way itself. In other words, we don't see necessarily individual stars in our own galaxy. We see this swathe of light crossing the sky. How distinct it is, how bright it is, depends mainly on how bright your sky is. If you live in an area with a lot of light pollution, then the background sky will be quite bright, and so it will be difficult to see the bright band of the Milky Way going across the sky. It's most prominent in the summer months simply because of how the Earth is positioned relative to the Milky Way, and so during the summer months the Milky Way for us goes across the sky quite dramatically. And if you can get away from any light pollution, and if you can pick a night where the moon isn't too bright, then the Milky Way is a spectacular sight. Again, it doesn't look the same as when you take a photograph, because when you're taking a photograph, you're adding up the light taken over many minutes, and it's not quite the same as the way you see it with your naked eye. One of the biggest differences is colour, because at night your colour vision is very poor, so you will see the brightness variations within the Milky Way, and you will be able to see, for instance, dark areas, these dark dusty areas that are blocking light from more distant stars, but it will be very difficult to pick out of the subtle colours that show up whenever you take a photograph. If we think about what can we possibly see in the night sky that's any further away than the stars in the Milky Way, then we start to think about our immediate galactic neighbours. For instance, the Andromeda Galaxy here. This galaxy, rather than being hundreds or thousands of light years away, this object is a couple of million light years away. So the light from this galaxy has taken about 2.5 million years to reach us. And again, when you look into the night sky, the photograph brings out all of the details in this particular galaxy. But if you were to look, you do have a chance of seeing this with your naked eye, but what you would effectively be looking at is the bright center, the bright nucleus of the galaxy. With the naked eye, you wouldn't pick up these satellite galaxies. This is Messier 32 and Messier 110. The Andromeda Galaxy itself goes under the designation of Messier 31. So with the naked eye, you would only pick up that central region. And with binoculars, you see more of the elliptical nature of this particular galaxy as we're seeing this spiral galaxy edge on. But again, you wouldn't expect to see all of the detail that can be brought out in a long exposure photograph. But still, the fact that you can, with your naked eye, see an object that is millions of light years away is still pretty incredible. It is not the limit of what you can possibly see with a photograph. It's essentially the limit as to how far you can see with the naked eye. But with binoculars or with photographs, you can go further than just a few million light years. For instance, I took an image where it's not particularly spectacular, but I took an image of a patch of sky where I knew, according to a star map, which I'll come to shortly, a star map told me that there were quite a few galaxies in this particular area of the sky. So I took a photograph, and then I started to compare what I was looking at in my photograph with what I would expect to see based on what I could find in an atlas. And in this particular case, all of the relatively small pinpoints of light are stars, but anything that looks a little bit bigger or a little bit fuzzier is a galaxy. So for instance, if I outline the galaxies, you can see there's quite a few of them, and they form this characteristic line, this so-called chain in the sky. This is called Markarian's chain. And the more you look, the more you find. That's one of the great things about this. You can do a little bit of archaeology. You can take a picture and then you can look in more and more detail, and if necessary zoom in so you see more and more of what's in there, and then you realize there are even more galaxies hiding in an image like this. One image I took of the night sky with a telephoto lens, I found at least 50 galaxies strewn across the image. Some of them I could only really identify by checking them against the star atlas. And these galaxies are hundreds of millions of light years away, between 50 and 150 million light years or so. So again, we're looking at objects, we're looking at light that has been travelling for hundreds of millions of years. The light that produced this image left these galaxies whilst dinosaurs were still roaming the Earth, for instance. But that's not the limit either. During COVID, I thought to myself, I wonder, how far can you actually go into the night sky? I remembered Stephen Hawking saying, don't look down at your feet, look up at the stars. And I thought, what a wonderful idea. Now that we're all kept at home by the COVID pandemic and the lockdowns, I thought, right, let's stretch my wings a little bit. Just how far can you see into the night sky if you use a camera? We know the limit for naked eye is a couple of million light years or so, but with a camera, just how far is the most distant object that you can ever hope to catch? So I looked up in a catalogue very distant galaxies, and I tried to find a galaxy that was bright enough that I have a chance of catching it. I took a picture. This is not the galaxy in the centre here. The galaxy is very faint and is sitting over here just to the right of this star that you can see in the middle of the image. The picture was taken with a camera on what I call a star tracker, what everybody calls a star tracker. A star tracker is just basically a box with a motor in it that will turn the camera at 1 revolution a day. As the Earth turns, the stars seem to move at the rate of 1 revolution a day in the opposite direction to which the Earth is turning. So if you put your camera onto a box which is turning at 1 revolution a day, it will follow the stars, as long as you get it lined up right. So in this particular case, this white box has got a motor in it, and by bolting a camera onto the front here and making sure that it's lined up with the North Pole, it will track the stars. And that allowed me to take a long exposure because this galaxy somewhere in here is very, very, very faint. So I set up a camera with a telephoto lens on this tracker, took a long exposure picture, hoping to catch this very distant galaxy in the middle of that square. And you can't see it there, so I had to really blow it up. And when I blew it up, I found that I had caught that galaxy. It's the most undramatic, unaesthetically appealing photograph you're ever likely to get of the night sky. But the point is, the light that produced that tiny dot there, that particular dot is a quasar. A quasar is just the name given to a galaxy with a supermassive black hole at its centre that is spitting out a huge amount of energy. So much energy is coming out of this black hole that we can see this object, we can see this galaxy, even though it is not millions of light years away, it is literally billions of light years away. This object is essentially on the other side of the observable universe. And yet a camera can pick it up. So again, it is not the most spectacular image. If I blow it up, you can see that this galaxy is barely a pixel in the image. But it's not the fact that I've imaged it and produced a wonderful image, it's the fact that I caught any light at all, which is absolutely amazing. The night sky is not simply full of stars which are very close to us, it's full of objects that are very, very distant. This particular galaxy that I imaged here is 25 billion light years away. The light has taken most of the age of the universe to reach us, so the light left this quasar some 12 billion years ago when the universe was very young, and it's taken all that time for the light to reach us. Because of the expansion of the universe, this object is so distant, actually it's receding from us at something like twice the speed of light, and yet it is possible to get a camera, put it onto a star tracker, take it outside, even with a few street lights around, and still grab an image of an object like this. So the night sky is full of objects that are very close, like the moon, but it's also got objects in which are unimaginably distant. And I find it incredible that modern technology, i.e. an SLR camera, a camera that's designed to take pictures in daylight, can actually capture the light from these very, very remote objects. So how can you find your way around the night sky? There's obviously lots of interesting objects up there to look at with the naked eye, to look at with binoculars, to look at with telescopes, to try and image with a camera. But how can you find your way around the night sky? Well, many moons ago, many years ago, many decades ago, I would have said to people, what you want to do is to get yourself a planisphere, a piece of plastic, two pieces of plastic in which you rotate one to line up time and date, and it shows you in this sort of oval window here, it shows you what stars you can expect to see in your night sky if you line up the time on one dial with the date on the other dial. So a very simple piece of equipment to tell you what constellation is in the sky tonight. But you could argue no one is going to bother with something like that these days, because everybody is going to get an app for their computer, for their laptop, for their tablet, or even their phone, which tells you what's in the sky. Here's just 3 of them. Other apps are available. Stellarium happens to be free, so that might be your first choice if you haven't got one. I have used Starry Night, I have used Sky Safari. They cost a few pounds each rather than Stellarium, which is free, but all of them do a very similar job. They can tell you what's in the sky tonight, and if it's on your phone, you can hold your phone up to the sky, and because the phone knows which way up it is and which way it's pointing, it can tell you what particular bit of sky is that you're looking at, and identify, for instance, the bright object in the sky over there is Venus or Jupiter. So the apps will give you an all-sky view if that's what you want. If you want to reduce the scale so you see every star in the sky, or at least all the constellations that are visible tonight. Some of you may recognize some of the constellations. There's the Plough, for instance. And the pointers of the Plough are pointing to the North Star Polaris there. And there's the Milky Way running across the sky. This is the view in the sort of summer months, as it were. This particular view was taken when? June, in the middle of the summer. And if you wish, you can zoom in to particular regions to say, well, if I were to look at the southern horizon, there's an S at the bottom telling you you're looking south. It will tell you what you can expect to see if you're looking towards the southern horizon. It names the stars, it shows you detail, it shows you star clusters, it shows you where the nebula are, etc. And if you keep the app up to date, it'll show you what meteors might be visible this month. It'll show you whether or not comets are passing by, etc. And if you zoom in, you can see what's going on with planets. For instance, if you looked on this particular night, if you zoomed into Saturn, you're not necessarily going to see Saturn in anything like that detail. But if you did get a small telescope pointing at Saturn, it would allow you to identify these little points of light that are floating around Saturn. These are some of its moons, some of its satellites, Rhea, Mimas, Tethys, Dione, etc. Titan is one of the brightest satellites, but it doesn't seem to be visible in this particular screenshot that I've taken. So you can get all sorts of information about the whole sky or part of the sky, or you can zoom in to look at craters on the moon, or you can zoom in to see what's going on with Jupiter, what's going on with Saturn, which moons are visible tonight. So these apps are very useful for helping you navigate your way around the sky. But what if you want to see more than you can see just with the naked eye? Well, if you have a few £100 or a few tens of thousands of pounds, you can go out and buy yourself a telescope. Telescopes will start in price from a few hundred, and there's almost no limit to how much you can pay for a telescope if you so wish. And that is why it is so confusing for anybody that's starting out. Regardless of how deep your pockets are, simply deciding which type of telescope should I buy is very confusing. Should I buy a very small compact telescope, which is very easily portable? Or should I buy a telescope which uses lenses? Or should I buy a telescope which uses mirrors to do the focusing? Would I be good to buy one that is based on a mount that goes left, right and up, down, a so-called Altaz mount? Or would I be better off having a telescope which is on a so-called equatorial mount, which is lined up with the Earth's pole to make it easier to track the stars? Lots of things to think about. Large telescopes are good for collecting lots of light, but they are heavy and, of course, expensive. So it can be very difficult to decide what sort of telescope you ought to be going for. Because I often get this question, what's the best telescope to buy for a few £100s, I started collating information. These are the prices you can expect to pay. These are the prices as of 2021. Now, we know prices have gone up a lot recently. It seems that telescopes haven't gone up that much compared to fuel and food and other things, but you might expect to add another 5 or 10% onto these prices. And the coloured bars here show you roughly how much you might expect to pay for different types of telescope. For instance, a refracting telescope that uses lenses versus reflecting telescope that use mirrors, and other types of telescopes which use a combination of mirrors and lenses. And here you can see, for a given sized aperture, you can see, roughly speaking, for each type of telescope, roughly speaking, how much you might expect to have to pay. It's obviously not definitive, it's just a guide to give you a ballpark estimate of what you can expect to pay. But one thing you do notice is that although it's nice to have the largest possible aperture to catch as much light as possible to do your stargazing, the size of telescope you can get changes for a given price band depending on which type of telescope you're thinking about. So for instance, if you're after a refracting telescope using lenses, then a 6-inch aperture is going to cost you quite a bit. But if you're happy to use a reflecting telescope where the mirror collects the light, well, a 6-inch telescope will cost you considerably less. So I'm not going to go through all of the pros and cons here. I'll make this chart available to you if anybody's interested in consulting this and giving you an idea of a sort of guide as to the pros and cons and different telescopes. One thing to bear in mind is there's a little gap in the top left there, and that's really because if you have got less than £100 to spend, most people would advise you'd be better off buying a pair of binoculars, a good pair of binoculars, rather than a really cheap telescope, unless you happen to catch a bargain second hand or something like that. You'd be better off going for a quality pair of binoculars. You'll probably end up seeing more than if you buy a really cheap telescope for less than £100. But given that I haven't got time this evening to go through the pros and cons of why you might choose this telescope over that telescope, I'll simply refer you to a different talk I've given where I've tried to put together a sort of rough guide to buying your first telescope. And I'll send you links to that. I'll send those to Mike so that he can pass them on to you. If anybody is genuinely interested and wants to know the details, you can go and watch that short talk about things to think about before you buy your first telescope. If you're going to buy a telescope, where are you going to put it? Well, you might just decide to put it on a tripod and put it in your back garden. But of course, we would love to have the opportunity to have a big dome in which we put our telescope so it's kept protected from the wind and protected from the elements. This is California, Mount Palomar, where I visited back in 1982 as a student. I think I might actually be wearing the same shirt this evening by the looks of that particular photo. So this photo is 40 years old. I visited the Hale telescope in California. I saw this dome and I thought to myself, one day I am going to buy myself a telescope and I am going to buy myself a house with a back garden that's big enough to have an observatory like that. Okay, I had to downsize my aspirations somewhat, so when I did buy a house and have a back garden big enough to house a telescope, I decided to have a shed, not something the size of the Palomar Observatory. And in that shed, which I then started to call an observatory, I put my little telescope. Little in the sense that I now have a slightly larger telescope. You can tell this picture is quite old, not from the telescope itself, but from the laptop that's sitting on the table in the background. The laptop looks like a brick rather than the very slim things you get these days. So yes, this picture is again the best part of 20 years old. Unfortunately, in the particular place where I live, I started with rather nice skies 20 years ago, but now lots of trees have started to grow. Perhaps you can see that in the previous picture. There are lots of trees. They have now got an awful lot taller, and so I am starting to lose part of my sky, quite a bit of my sky, simply because all the trees, which are not mine, have been growing around my garden. Bit of a shame, but there's not an awful lot you can do about that. For our students at the universities, and by universities I mean Liverpool John Moores University as well as the one in which I work, University of Liverpool, because there's not much real astronomy you can do under dark skies in the UK, we decided that it would be a good idea to take our students, our astrophysics students, out somewhere where they can enjoy real dark skies. So once a year, at least once a year before COVID, we took them out to Tidy Observatory on the island of Tenerife. In that little black rectangle you can see in the distance, just on the edge of the caldera of the central volcano, is the Tidy Observatory, a number of different telescope domes, some of which are used for solar astronomy, but some are used for nighttime astronomy. And the advantage of being up high on top of a volcano is that when night comes and the sun has set, essentially all the clouds are below you. There are occasionally very high clouds, but 99% of the time the cloud bank is below you, and hence you get glorious clear skies. Even though there's a few tourists down there on the beach or at the nightclubs, up on the volcano, nice clear skies. So that's a great place to take students to show them what a night sky ought to look like. In this particular case, the student is using an old telescope which is no longer used for research purposes. It's used for educational purposes. And here the dome has been opened during twilight as we wait for the darkness to fall. So yes, it's nice to be able to go to dark skies to take photos, but maybe you would like to take photos here in the UK. So it's nice to see things with the naked eye. It's nice to see things with binoculars. It's nice to look through a small telescope. But can you take photos for yourself? And the answer, of course, is yes, you can. So you don't have to have any special equipment. This is another oldish picture I took more than 20 years ago now, I think. And here it's just point the camera at the sky and leave the shutter open, in this case for a few minutes. I was pointing north and, whoops, just banged the mouse. I'm pointing north and this is Polaris here in the center, and you can see all the stars appear to have rotated a little bit around the Polaris. Everything seems to have moved in a little bit of an arc. It was only a 5-minute exposure, so the stars haven't moved much, and Polaris is so close to the pole it's hardly moved at all. Stars further away from the pole seem to have moved a little bit further. So if you're interested in just taking star trails, it's by far the easiest thing to do, because all you need to do is to put the camera somewhere where it's not going to move. Put it down on a table and prop it up, or if you have one, put it on a tripod and point at the sky and take a picture like this. This was with photographic film, but you can do exactly the same with digital images. So this is a picture I took in Tenerife with the telescope dome in the foreground there. And again, you can see the star that doesn't appear to move is Polaris, and all the other stars appear to have rotated around it. Some of the arcs of stars don't look quite like the arcs of a circle. That's simply because this wide-angle lens is just distorting the view ever so slightly. So you can take a picture over a few minutes, or over 10 minutes, or over half an hour, or if you have the patience, over many hours. Generally speaking, these days with digital photography, people don't tend to leave the camera shutter open for hours at a time. It's more sensible to take a lot of short exposures rather than to take one long exposure. And if you do that over a long period of time, you can end up with an image like this. The foreground is quite well lit, which gives the impression it was taken during the day, which of course it wasn't. This is simply a night in which there's a full moon illuminating the other observatory domes and the grass in the foreground, and so the full moon is lighting up the foreground and making the sky look a little bit bluer than it normally is. But you can tell this is a long exposure simply because the length of these trails, you can see that that's almost 1/4 of a circle. And given that the Earth rotates once in 24 hours, you can see that this is approximately a 6-hour exposure. You can also see from this that although Polaris is close to the North Pole, it isn't actually at the North Pole. Polaris itself makes a little bit of an arc as it moves in a small circle around the North Pole. But the advantage of taking a lot of short exposures and then adding them all together in software, there's free software that will do that for you if you want to give this a crack. The other advantage of taking lots of short exposures and then adding them together in a longer star trail is that you can add the short exposures together into a video. And here we see the streaks of the stars forming as we add lots of images together and show the result as we go on. So you can see you get this impression of the sky rotating. And again, it's the same 6-hour exposure that I showed last time, but just presented now as a movie rather than presenting it as a single image, which is the result of adding together all the exposures. In this particular case, I think I took one exposure every minute for 6 hours. So yes, you end up with a lot of images on your SD card, but given that digital photography, it's not like you're wasting film as it would have been in the old days with photographic film. Here with digital images, if you're taking a few hundred images, well, SD cards these days are big enough that that is no real problem at all. So we're just coming to the end here of the 6-hour exposure as we get to the point where we get 1/4 of a circle around the pole. But of course, you don't need to use a telescope, and I've already told you that an alternative is a so-called star tracker. A tracker is simply a box which moves the camera at 1 revolution a day. If the camera is static, the stars will appear to trail into star trails. But if you want to keep the stars as points of light, then the camera will have to move in the opposite direction to the Earth's rotation to keep all the stars nice and sharp. But my point here is that you can get some rather nice images simply by putting a camera on a tracker. You don't have to think about the only way of getting really great images of distant objects is to take a picture through a telescope. I need to buy hundreds of pounds worth of telescope or thousands of pounds worth of telescope and a really flashy camera in order to get nice images. No, you can use the camera you've got anyway. The camera I use for astrophotography is the same camera I use for taking pictures of zebra in East Africa. It's my standard camera that I use for daylight photography. It is not a special astro camera. It hasn't been modified for astrophotography. It's just a normal daylight image, and you can end up taking pictures like these that I've been showing you this evening. Yes, you can buy yourself a telescope, and yes, you can put a camera onto the end of a telescope and produce some fantastic images, some of which you might have seen in astronomy magazines, for instance, or occasionally they show up on Astronomy Picture of the Day webpage. So yes, you can get some fantastic images if you're prepared to invest a fair bit of time, because it takes a little bit of time to work out how best to do astrophotography with a telescope. It takes time, it takes a fair bit of effort, and it takes cash, because the sort of telescope and the sort of mount that you need to do exposures over many hours with the sort of results that you tend to see in magazines, yes, that can sometimes take many thousands of pounds worth of equipment. But the sort of pictures I'm showing you on this particular screen, taken with an ordinary camera and a star tracker. And a star tracker can be almost anything from a star tracker that you build yourself. I built this particular star tracker. I've given it the name K2. I built it quite a few years ago. When was it? 2007. So again, this tracker is now quite old, 15 years old or so. And you can build a tracker like this for yourself for about 10 or 20 pounds or so. So if you've already got a camera and a wide angle lens and a telephoto lens or even a zoom lens, you can build yourself a star tracker for 10 or 20 pounds and then take pictures of the night sky. This is what is called a barn door tracker. Basically, it's just a couple of hinged pieces of metal that are driven apart by a motor. So down here there's a motor which turns a thread which makes this top arm move relative to the bottom arm, and it's hinged at this end. And as long as that hinge is lined up approximately with the Earth's axis, then this arrangement will move the camera in the opposite way to the Earth and allow you to take images of stars that are pinpoint rather than star trails. So I built this myself for a bit of fun. Again, I can give the link to this if anybody's interested, a link for the instructions as to how you can build one of these for yourself. But as of a few years ago, I decided to buy myself a commercial star tracker, effectively a motor in a box. The commercial star trackers will start at about £100 or so, and you can, if you wish, spend £2 or £3 or more £100 on a tracker if you start to get interested in astrophotography. You don't have to leap straight to one of those. If you've got a little bit of nous and you enjoy building things yourself, then you can build yourself one relatively cheaply. But these trackers are great for taking, for instance, wide-angle views of the sky. You don't need very high precision. You don't need to line them up with the Earth's axis very accurately if you're taking a wide-angle chunk of sky. You have to be a little more careful if you're using long focal lengths, because then it is more critical that you've got things lined up correctly and that the tracker is moving at the right speed. This particular image of the Milky Way, taken from a dark sky site, was taken with a 10mm wide-angle lens. That's the focal length of the lens, not the aperture. Focal length of 10mm means you get a very large chunk of sky. In this case, the constellations all the way from Cygnus down to the constellation of Scorpius. And the centre of our galaxy, the centre of the Milky Way, is somewhere embedded in this rather dusty environment here, approximately where the cursor is pointing now. And so when I took this photograph, I rather liked the idea of getting a large chunk of the Milky Way, but I also thought it would be interesting to look in a bit more detail around the centre of our galaxy. So with a different focal length, I changed and looked at that area with a 35mm lens, and that gave me this image here. So more detail, it's the same image I showed you earlier, more detail in terms of the dust clouds, some of the bright regions of the Milky Way and some of these dark areas. This is dark, dusty material which is hiding the light from more distant stars. And so you can see this structure in the Milky Way. That's our old friend Antares, the brightest star in Scorpius, the region I showed you with the rather colourful dust clouds earlier. In this particular case, we happen to also have caught the planet Jupiter, and over on the left-hand side, there's the planet Saturn, rather less bright compared to Jupiter. But in a wide-angle shot, a 35mm would still classify as a wide-angle lens. In this particular case, again, if you wanted to, you could zoom in and look at more detail and see, for instance, the Lagoon Nebula, the Trifid Nebula, the Swan Nebula, the Eagle Nebula. Lots of star clusters, lots of nebulae show up even with a wide-angle lens. You perhaps don't see a huge amount of detail, but you can pick up all of these objects, dark regions of the Milky Way, star clusters, star nebulae. And so a wide-angle shot can still produce a huge amount of detail and produce an aesthetically very nice shot. So when you look at images like this, you say, well, okay, these are all very nice and they were taken with the star tracker, but presumably they must have all been taken from very dark skies in order to get images like this. I live in an area with streetlights. I couldn't possibly get images like this. Well, bear in mind that, yes, 3 of these images, the ones I'm showing here in the middle, were taken from relatively dark sky sites where light pollution was not a problem. But the picture of Andromeda over in the top left, that was taken from Herefordshire in the UK. The picture in the bottom left, the picture of the Rosette Nebula, just a little bit further east of Orion, that was taken from the back garden of a friend of mine who lives south of Birmingham. And this picture on the right-hand side of the Veil Nebula, the supernova remnant, supernova that's blown itself apart a few thousand years ago, that picture was taken just a few meters from where I'm sitting at the moment on my front drive, about 10 meters from a street light, and it was taken on a night where the moon was up. So even if the moon is in the sky, even if you have street lights close by, it is still possible to get nice pictures with an ordinary camera from the UK. Now, I have to just put in a caveat. And that is, if you do have an awful lot of light pollution, then the only way of making sure that that light pollution doesn't completely spoil your images is to try and filter that light pollution out. To some extent, you can do that with software. You can take an image and you then end up with a digital image, and software sometimes allows you to get rid of some of the bright sky that you would get if you live in light polluted areas. But also it's possible to buy filters which you can use either on your telescope or on your camera for astrophotography, and those filters can allow you to mitigate the effects of light pollution and to some extent mitigate the effects of a bright moon in the sky as well. I'm not going to cover an awful lot of detail about that because I've only just started to investigate the possibility of using filters to reduce light pollution, and I'm now starting to put a talk together, and perhaps in a couple of months that talk will be ready, in which I can say these are the pros and cons of using filters to take pictures of the night sky to mitigate the effects of light pollution. So watch this space. That could be ready in a short while. One final thing to think about, and that is because, yes, in the UK we don't get the best of weather, and in the UK we are often within a few miles of a town or a city which is producing a lot of light pollution. But remember, if you're the sort of person that likes to go on holiday and get away from it all, maybe you visit some places in the world that are quite a distance from streetlights. So for instance, I have a hobby of astronomy. I also like photography, but I also enjoy taking pictures of wildlife. So for me, the ideal holiday is to go on safari, because with a pair of binoculars and a camera, you can watch the animals, you can photograph the animals by day, and by night you can observe the sky with binoculars, and if you've got a star tracker, which is a very compact box which you can take with you on your travels, so again you don't have the luggage restriction of a large telescope or a large mount, a relatively small tripod and a tracker will allow you to do astrophotography. And a safari in East Africa not only takes you to where the animals are, it also means you get away from towns and cities and streetlights. So you could argue that's absolutely ideal. Photographing animals by day, photographing the stars at night. Basically sleep when you get home. So I'm not suggesting that you go on safari, I'm just saying give it some thought that if you are going somewhere in the world where you are getting away from streetlights, if you're going to spend some of your time out in the wilds, remember, not only is that a great place to visit during the day, think to yourself, can you actually go out into the middle of nowhere, get away from light pollution, and then enjoy the dark skies of whatever country you happen to be visiting? Because of course, the night sky should be there for all of us, and if we can get away from light pollution, then we can enjoy it not only with astrophotography, we can enjoy the wonders of the night sky with naked eye observing. So I hope that's given you something to think about this evening. Thank you all for listening.